Welcome, class, to the Intro to Java Programming.
In this lesson, we will review the different types of errors that can happen while developing the application, how to handle these errors, and some code examples. Murphy's Law states, if anything can go wrong, it will. When you write an application, things can and will go wrong. These are called errors or exceptions. There are two main types of errors, compile time errors and runtime errors. A compile time error is typically a syntax error made by the developer like int age equals Coach Joe. An int variable cannot hold a string value. The application cannot be started with compiler errors. When the application compiles successfully and is running, there can be an unforeseen event that causes an exception error. When an unhandled exception occurs, the application stops. You have seen this many times. An operating system crashes, an application stops responding or closes without warning. Exceptions are common while developing and testing new applications. These errors are out of the developer's control but can be detected, prevented, and handled gracefully. Imagine the application supports the company website. An exception error that stops the application will mean your company is no longer generating revenue. Turning off the flow of money will attract negative attention from many managers and all the customers. It is your goal to avoid this. To prevent exception errors from occurring, you need to understand two key factors. Recognize coding actions that can cause an exception in the first place, and catch or handle the error before it stops the application. Here are some common coding situations that can cause an exception. Anytime your application communicates with another application, whether it resides on the same server or another, for example, communicating with databases, files, and web services are common situations. Null pointer exceptions, or NPE. An object is expected to have a public property, but instead the object is null. Division by zero, and getting an element of an array or list that is outside the allowed boundary. There can be many others, but this should give you an idea. Exceptions can be caught with the use of the try, catch, and finally blocks. Here is the syntax. There is a keyword try followed by a code block. There can be an optional catch keyword followed by a code block, and there can be an optional finally keyword followed by a code block. When using the keyword try, there must be a catch and or finally code block. Inside the code block for the try is a command that could generate an error. The catch code block will only execute if an error is detected, and the finally block will always execute after the try and catch blocks regardless if an error was detected or not. This is a great place to perform any final actions while handling this possible exception. Let me show an example of the try, catch, and finally statements in action. Let's go to our first program project in IntelliJ, close any open class tabs. Let's create a new package called exceptions. Let's create a new class called try, catch, finally. Here is the public static void main method. This private method, runApp, will call example methods to better explain the try, catch, and finally blocks. This first method will show a standard example. Here we declare an array and another int variable. Inside the try block is code that has the potential to generate an exception error, like accessing an array element by a specific index. If everything goes correctly, the result will be displayed. If anything goes wrong inside the try block, the catch block will execute. E is the exception identifier representing the exception that occurred. Here, the error message is displayed. Because the exception error was caught, the application will not stop unexpectedly. It will continue to run. Regardless if an exception is caught or not, the finally block will execute and display this message. Let's run the code. Inside the try block, we get a specific index from the array. Index 1 points to the element that contains the number 20. This line will output the result. No error was encountered, so the finally block is executed. Here you can see the output from the try block and the finally block. Let's change the index to 5 and see if the error is caught. Let's run the code again. Notice the output. Index 5 out of bounds for the length 2 is the error message. The error occurred here. These two lines were not executed. Instead, the next line of code is inside the catch block. Here's an example of just try and catch. Let's comment out this method. And let's call the new method. If we run the code, the same result happens, less the finely blocked display output. The use of a try and finally block without a catch block is allowed. Unless you have a specific need, it is uncommon and may be an indication of a poorly designed process. It is recommended to have a catch block with all try blocks. There can be more than one catch statement for a given try block. Here's an overview of the try and catch blocks. The try executes code that could cause an exception error. If you know that multiple possible exceptions could occur, you could have one or many catch blocks. We have seen an example of this catch block where the parameter is exception E. Exception is considered to be an unconditional exception, meaning it will catch any error. Some catch blocks are designed to only catch a specific exception error. These are conditional exceptions. This catch block will only catch index out of bounds exceptions. This catch block will only catch arithmetic exceptions. When an exception occurs inside the try block, the code will jump to the first catch block that allows that type of exception. Let's look at some code to see. Here is a method called multiple catch blocks. Inside the try block, a random number is generated with possible values of 0, 1, or 2. Array result will get a specific element of an array. Notice only indexes 0 and 1 are allowed. Here, division result will divide the number 12 by the random number. Notice that only 1 and 2 will be allowed because you cannot divide a number by 0. 2 out of 3 times an exception error should occur. This catch block will only catch index out of bounds exceptions. This catch block will only catch arithmetic exceptions. All other errors will be caught in this catch block. Let's comment out this method call. Let's add a new method for the multiple catch blocks method. Run the code. Notice the try block completed. There were no exception errors. Let's run the code again. Notice there is an arithmetic exception. Let's run the code again. Notice there is an index out of bounds exception. Time for a Coach Joe challenge question. Which catch block is executed when there is a division by 0 exception error? Block 1, block 2, or block 3? The correct answer is block 1. This catch block will catch all exception errors. Since the code is looking for the first catch block that can handle the exception, this code block will be used. It is important to remember, place the unconditional exception block as the last catch block to allow conditional exceptions to be caught first. Here is one more example of catching and handling exception errors. This method will get an integer number from the user with the scanner object. This loop will keep prompting the user for a valid number. Inside the try block, we get a string input from the user. This line will convert that input into an integer. What if the user provides letters instead of a number? There will be an exception error. Display a friendly error message and the loop will start again. Once the user provides a valid number, the result is displayed and the application ends. Let's comment out this method call. Add a call for the new method. Let's run the code. Let's enter the letter J. We are prompted to enter a valid integer. Let's enter 7.3. Again, we are prompted to enter a valid integer. 7.3 is not a valid integer. It is a double or a float. Now enter 42. The application ends after displaying our number, 42. Here's a summary of all the code we wrote for this lesson. You should now have an understanding of compiler and exception errors, including common situations that require these exceptions to be caught. The try, catch, and finally blocks were explained along with several code examples. Because Murphy's Law states, if anything can go wrong, it will, it is in your best interest to predict situations that could cause an exception error and handle them gracefully. Unhandled exceptions could cause the application to stop unexpectedly. In the next lesson, we will discuss pseudocode, logic, and build our first application.
Remember, future senior developers, make it work, prove it works, then make it better.
Ready? Break!